Astronomy, the Science of the Heavenly Bodies by David Todd. Measuring the Earth, Eratosthenes. All told, the Greek philosophers were probably the keenest minds that ever inhabited the planet, and we cannot suppose them so stupid as to reject the doctrine of a spherical Earth. In fact, so certain were they that the Earth's true figure is a sphere that Eratosthenes in the 3rd century BC made the first measure of the dimensions of the terrestrial sphere by a method geometrically exact. At Syene in Upper Egypt, the sun at the summer solstice was known to pass through the zenith at noon, whereas at Alexandria, Eratosthenes estimated its distance as 7 degrees from the zenith at the same time, this difference being about 1/50th of the entire circumference of a meridian. Eratosthenes correctly inferred that the distance between Alexandria and Syene must be 1/50th of the Earth's circumference. So he measured the distance between the two and found it 5,000 stadia. This figured out the size of the Earth with a percentage of error surprisingly small when we consider the rough means with which Eratosthenes measured the sun's zenith distance and the distance between the two stations. Greatest of all the Greek astronomers, and one of the greatest in the history of the science, was Hipparchus, who had an observatory at Rhodes in the middle of the 2nd century BC. His activities covered every department of astronomy. He made extensive series of observations, which he diligently compared with those handed down to him by the earlier astronomers, especially Aristotle and Timacharis. This enabled him to ascertain the motion of the equinoxial points, and his value of the constant of precession of the equinoxes is exceedingly accurate for a first determination. In 134 BC, a new star blazed out in the constellation Scorpio, and this set Hipparchus at work on a catalog of the brighter stars of the firmament, a monumental work of true scientific conception, because it would enable the astronomers of future generations to ascertain what changes, if any, were taking place in the stellar universe. There were 1,080 stars in his catalog, and he referred their positions to the ecliptic and the equinoxes. Also, he originated the present system of stellar magnitudes, or orders of brightness, and his catalog was in use as a standard for many centuries. Hipparchus was a great mathematician as well, and he devoted himself to the improvement of the method of applying numerical calculations to geometrical figures. Trigonometry, both plane and spherical, that is, and by some authorities he is regarded as the inventor of the original methods in trigonometry. The system of spheres of Eudoxus did not satisfy him, so he devised a method of representing the paths of the heavenly bodies by perfectly uniform motion in circles. There is slight evidence that Apollonius of Perga may have been the originator of the system, but it was reserved for Hipparchus to work it out in its final form. This enabled him to ascertain the varying length of the seasons, and he fixed the true length of the year as 365 1/4 days. He had almost equal success in dealing with the irregularities of the moon's motion, although the problem is much more complicated. The distance and size of the moon by the method of Aristarchus were improved by him, and he worked out for the distance of the sun 1,200 radii of the earth, a classic for many centuries. Hipparchus devoted much attention to eclipses of both the sun and moon, and we owe to him the first elucidation of the subject of parallax, or the effect of difference of position of an observer on the Earth's surface as affecting the apparent projection of the moon against the sun when a solar eclipse takes place. Whereas an eclipse of the moon is unaffected by parallax and can be seen at the same time by observers everywhere, no matter what their location on the Earth. Indeed, with all that Hipparchus achieved, we need not be surprised that astronomy was regarded as a finished science and made practically no progress whatever for centuries after his time. Then came Claudius Ptolemaeus, generally known as Ptolemy. the last great name in Greek astronomy. He lived in Alexandria about the middle of the 2nd century AD and wrote many minor astronomical and astrological treatises, also works on geography and optics, in the last of which the atmospheric refraction of rays of light from heavenly bodies, apparently elevating them toward the zenith, is first dealt with in true form.